Good afternoon. My name is Elias Tsiatas from Comptek Solutions. I'm the Sales and Business Development Director. I give you first a short company overview. So we are founded in 2017 as a spin-off from the University of Turku in Finland. We are 27 people, and our collaborations cover several target industries for us, like power, RF, micro LED, laser, quantum, and substrates. In our facilities, we have a state-of-the-art labs, including several ultra-high vacuum reactors and also ISO 5 clean room and outstanding characterization capabilities to support the technology. The solutions we offer is passivation technology for 3-5 compound material-based semiconductors, and the business model is based on technology transfer with that includes equipment and IP license. The technology itself, we think that the one bottleneck in the semiconductor industry, especially with 3-5, is the interface between those materials and the thin films, where we see very high defect density. So what our technology is doing, Controx, what is doing is that we replace the default interface that is an irregular amorphous oxide layer, as you can see here in the picture. We replace this with a very stable, high quality oxide that comes prior to any thin film method like ALD or PCVD. And that offers a very self-limited thin layer that is very stable and contributes to surface reduction, defect surface reduction of 90-80%. Or up to 90-80%. Then the devices we can treat with our technology are sidewalls, like micro LEDs, for example, or laser facets for high power, let's say lasers is a good example, interfaces for transistor or RF applications, and also substrates. And we can treat different combinations of 3-5 compound materials, as you can see here from the screen. Some examples of the technology effectiveness and is, for example, the interface. Here we have pictures, lead pictures from a gallium nitride wafer that is clean, and then we have start growing our Controx oxide, and you can see that it's a very well-defined oxide with a very specific structure, and it has a very good stability towards air exposure that lasts for weeks, I would say. And in this example, we help to reduce the density of intensity traps for the electrons and also to increase the electron mobility. Another example of this technology is the lifetime, and here I use as example high power lasers. So you can see on the picture on the right that after 1,000 almost 500 hours, we see that a Controx passivated laser bar maintains a relatively high power level compared to the standard reference method that is being used in this example by the customer. And finally, if we think about the new tool that we have here, you can see the picture of the new tool here in the on the right corner. The performance of micro LEDs is a very typical example of Controx role in passivation, because you can see that we can contribute to chip size reduction. For example, a 5 micrometer chip can perform as good as a 40 micrometer chip if it is Controx passivated, because in this example here, by the way, it's a 5 micrometer micro LED blue gallium nitride technology. And also you can see in the picture how different is the brightness level between those two, a standard one without Controx passivation and then the Controx passivated LED. So the new thing here about the Controx technology that supports our activities is the wafer pilot line 200 millimeter that has ultra high vacuum reactor, of course, is the basic thing where the magic is happening. And then, of course, it's supported by other elements. I would emphasize the ALD, uh, ALD equipment connected to that, also the glove box for pre-production or development purposes, and of course, a storage chamber that give us a lot of flexibility. The equipment, you can see another picture here, can support several wafer sizes. 200 millimeter is the biggest one, but we can do also 6, 4, 3, and so on. Even more interesting is that we can support also customized holder designs, and we can do also different small sample sizes down to 12 times 12. And it's a fully automated system that give us also the speed we need. And of course, it's connected to clean room. Some of our activities now that we want to support with this new R&D equipment have to do a lot with photonics. And the first results are already here. On the left page, you can see a 200 millimeter wafer from blue micro LED gallium nitride. And you can see that we have measured, we have applied our Controx passivation. We have done several measurements. Here we have 5 different points. So Controx A, B, C, D, E represents 5 different points on the wafer. And we can see that we have managed to increase the performance of the LED compared to the reference. And here I must say that we have applied first time ever a Controx recipe to an 8 inches or 200 millimeter wafer. There is, of course, a lot of things to do here in order to increase further the shift to uplift the performance of this micro LED. And of course, we plan to do also other things here, not only the blue, but also the red and the green micro LED in different sizes. Also, with this tool, we are treating also quantum IC materials, also 3.5 substrate passivation for some infrared applications. We are involved also in a European defense project. And not to forget, of course, outside the photonics, also the power transistors and the RF transistors as well. And then with our mass production laser tool, we are in all, I would say, in all main high power laser applications, gallium arsenide, indium phosphide, also gallium antimonide, and as new thing, we explore also the gallium nitride visible lasers for passivation. And finally, in order to get a good understanding of what we are doing, we need, and we have developed characterization systems. And the new product is a smart fab that can give to the customer and to us also visibility of several things that we need to measure, understand, and also correlate each other in order to understand what we're doing. Last but not least, a few words about our business model. So we start with a proof of concept in order to demonstrate to the customer how we can treat their wafers, their material, and then a successful proof of concept leads to technology optimization within a development agreement, where also equipment is asked. So for wafers, we have this new tool that you saw, and of course, partnerships with some world-leading semiconductor equipment manufacturers. And of course, for lasers, we have our own tool, our own passivation system. And finally, what we sell to the customer with the technology transfer is a license agreement to operate the technology. Thank you for your attention.